My name is Angel, and I'm here to talk about logarithms and what they are used for. A logarithm is the inverse of an exponent. So basically, what exponent can I raise this number to get this value? This is what it looks like. How this works is, this little part is your base. The number next to your log is a result of applying a power to that base, and your answer is that power. When you rearrange it, it starts to become a bit more clear what you gotta do. This is called exponential form. To solve, you just need to remember your powers. If you can't remember a whole power, or one cannot be found, then you would have to change base, which is when you put the log of your answer over the log of your base, like this. And when I mean answer, I mean the result of applying that power to the base. When changing base, it is best to use a calculator to find your value. Quick example, log base 3 of 27 is equal to what? If you can do it on your own, pause and solve it yourself. If not, stick around a bit for the process. Done? You should have gotten 3. If you reorganize your log into exponential form, you will get 3 to the power of x is equal to 27. 3 to the power of 3 is 27, so your answer should be 3. Yeah, you could use change of base like this, but it will take longer to do so and will require a calculator. It is best to use this method if you know that the value of your power is not going to be a whole number, such as log base 5 of 21 is equal to x, which would equal about 1.89 if you do the change of base. There's also expanding and condensing logarithms, which I'll quickly touch on. Just to quickly note, the base must be the same the entire way through, and you cannot condense or expand logarithms with different bases. Big no-no. If a logarithm is set up like this, then it equals log base b of x plus log base b of y, and vice versa. If a logarithm is set up like this, then it is equal to log base b of x minus log base b of y, and vice versa. And if a logarithm is set up like this, then it is equal to the log of base b of x to the power of a. Remember, you are applying a to the x only if you change it to this method. But if you keep the latter form, you multiply a to your entire log, which is cleaner in my opinion. Once you do find out the logarithm, that is. These can be in combination with each other, like this. And in this case, you should just do this. Apply a to all parts of the ratio, then expand the quantity of log base b of x to the power of a plus log base b of y to the power of a minus log base b of z to the power of a, and this is just one combination you can be method with. Again, this works the other way around. For more in-depth talk about condensing and expanding, click the video in the description by Joe Sharavone, because I only have so much time to animate and I still need to get to my topic. They're used in the real world quite often, actually. A good example is decibels. Sound is measured in decibels, along with power level and voltage. The Bell in decibel comes from Bell Telephone Labs after Alexander Graham Bell, the group that has created the system, while deci means 1/10. That means that 1 decibel literally means a 10th change in sound, voltage, etc. But from this point on, I'll be only talking about sound intensity. Decibel values depend on how far, loud, and fast the sound is traveling. The equation to use to calculate differences in decibels is 10 log P2 over P1. P is equal to power, with P1 representing your reference sound power, and P2 representing the actual power compared to your reference. And your answer is how loud a sound is in the current situation. Keep in mind, this is also important, because when a question gives you the decibel, this is basically your answer, unless there's more than one thing going on, which I'll explain later. For calculating from threshold sound, you can just use 10 log I, where I is equal to how many times louder a sound is than the threshold. Technically, the equation is 10 log I over I0, where that I0 means your threshold sound, but I becomes how many times louder a sound is times I0, as in I can become 2I0, 3I0, etc. So the I0 is basically cancelled out. Threshold sound is basically the quietest sound the organism perceives. Since humans have different hearing setups compared to a dog, cat, bird, whatever, but we typically use humans because, you know, we're humans. But basically, in a nutshell, this tells you how many decibels louder it is from threshold sound. Although you do not need this value, but it is important nonetheless, the threshold sound for humans is typically 4 decibels, which is about 60% quieter than in breathing at 10 decibels. Yes, there are sites that list average decibel values, such as BYJU's chart here, but it is also important to calculate when multiple sounds are playing simultaneously, or you only know how much louder a sound is from the threshold, and most chart values are only averages or approximates, and depending on how close and far they are as well. Here's a problem. Let's say you have a couple of air horns. These air horns are about 130 decibels at 2 feet away. About how loud are they? First things first, when calculating sound intensity, it is not as simple as adding up the decimals. You need to plug it into the equation. For example, if 2 people are talking at the same volume with the same intensity, are they twice as loud? No. Louder? Yes, but not twice as loud. Now that is settled, let's put these values into the equations. Our reference level is 130 decibels, so that would be P1. Since there are 2 air horns, your P2 is actually equal to 2 P1. Now, don't solve yet. Do not plug in your values. You need to expand the equation first, then it gets easier from here, and I'll show you why. This leaves you with 10 log 2 plus 10 log P2 P1. That 10 log P2 over P1 becomes 130 decibels, because that's how loud the air horns are. The reason that is replaced is because that's basically your sound intensity. They already gave it to you. But the reason you expand it is because you need to also add in the decibel gain, which is on the left. If you solve it just as it is, you will only get the decibel gain, not how much it is total. Yes, you could add it to your given decibel count, but this makes sure you have all the parts with it. Solve for 10 log of 2, which is equal to about 3 decibels. So 3 plus 130 is 133 decibels. So 2 air horns going off at the same time is about 133 decibels. Now, here is one on your own. You have a group of 10 people talking. Human conversation is at about 60 decibels. How loud is that group? Here's the equation for reference. I'll give you a minute. Pause if you need to. Done? Okay, let's see how you did. You should have gotten 70 decibels. Why? Do the same process as before. Replace that P2 with 10 pi, since pi is 60, and 60 decibels times 70 would be your actual power compared to 60. Expand your equation, input values, then solve, and you get 70 decibels. If you were to become an audiologist, knowing decibels is kind of important, especially since audiology is the branch of medicine responsible for hearing, balance, and other related disorders. As an audiologist, you need to understand how sounds will affect hearing and which ones are dangerous to humans. 85 decibels and above is dangerous, and every 3 decibels after that, the safe hearing time cuts in half. You can be exposed to 85 decibels of sound for 8 hours before it is dangerous, 4 hours at 88, 2 hours at 91, and so on. Hearing is important since the sensory hairs in our ears do not grow back, so once they are gone, and we go deaf. Hearing is key for balance, so if you would lose your hearing, you'd be a lot less balanced. Audiologists treat these kind of issues once they identify that the issue was due to prolonged exposure to loud noises, and these doctors often warn their patients of loud noises that exceed 85 decibels, such as those near or work at construction, and prescribe hearing medication and aids if needed. Well, that's it for this video. If you'd like to listen to some bloopers, click here. Due to AP testing, an animated version will not be out for a while until I clear that hell. Although I do have a main animation channel, I'd much rather not link it at the moment, as the animations on there are quite old and outdated and do not reflect my current skill. Maybe in the future I will link it, but time will tell. Anyways, this is Angel, and see y'all next time.